Welcome everyone, my name is Connor McDonald. I'm your host on this podcast called The Spoken Nerd. This podcast is sponsored by, no, I'm just kidding. There's no ads on this podcast. This is purely about talking tech and the tech community. I came up with the term The Spoken Nerd as a pun on the term spoken word, but as my partner would often say, she thinks it's more of a pun on outspoken, because I tend to never shut up about technology. But hopefully there'll be something in this podcast for everybody. Today I want to talk about a couple of things. One is the concept of how we should act and behave on a tech community, such as the Oracle forums or Stack Overflow or on Twitter, etc., because it was actually a particular question on Stack Overflow that was the inspiration for this podcast. But I'll get to that later. The series of podcasts I want to do for the next few months or so will be getting back to basics, getting back to how the actual database works, what are the core structures, and in particular, and rather than going back to basics on one of my other mediums such as YouTube or blogs, where we have the luxury of obviously video and diagrams, etc., I understand that in the world of 2020 and now 2021, there is a lot of virtual content out there because most of our conferences are being done virtually. And there's so much good content out there, which is a great thing, that I found that now people are struggling to actually find the time to actually absorb that content. Hence, doing it as a podcast will hopefully let you do some learning about Oracle basics on your daily commute or your daily run or daily workout, such that you can actually multitask your time more effectively rather than having to sit down and read a blog or watch a YouTube video. But back to the Stack Overflow question that prompted the podcast. Someone had installed SQL Developer and then had started the product and tried to connect to the database and was getting a TNS error. What concerned me was the amount of vitriol that then came back through people trying to, inverted commas, help this person. The first kind of responses were, well, you should just Google that error code or RTFM or let me Google that for you, etc. A lot of sort of nasty things really that weren't helping, more just a way of slamming this person for not understanding the basics. As it turned out, the reason they couldn't connect was they hadn't actually installed a database and didn't have one to connect to. They had misinterpreted the idea of SQL Developer as being a complete tool in terms of having both the IDE and the database as part and parcel of the single product. For someone who's obviously quite new to Oracle, this is an understandable error. But one of the people that was being quite nasty on this list of comments threw in a, well, if you can't connect to your database, you obviously need to start your database. It was at that point I decided I would enter the comments, or enter the chat as they say. And it reminds me of I was watching a Ricky Gervais comedy show recently, and he had this expression, I should have left it, which is when he's on Twitter and people are engaging with him back and forth and make inflammatory comments. He always says, you know, I should have left it and not engaged. And I was the same. I should have seen some of these comments and said, look, it's just not worth it jumping into this and just inflaming things. But we all have our failings. And because this person had said you need to start your database, I wanted to effectively just take them down a peg because I thought they were being rude to this obviously person who was new with Oracle technology. So I said, actually, you don't start a database, you start an instance. And rest assured, that's me just pretty much being petty. And I always know when I'm being petty because if I start a sentence with actually, really, you're just being derogatory to the person who made the initial statement. And please, if you ever see me say actually on a blog post or on Twitter or on a YouTube video, please call me out on it because it's really something I don't like to do. It's really you shouldn't be doing it. But as I said, we all have our failings. I'll come back to behavior on community later on in this podcast, but as I said, this one is really about going back to basics. And since we don't actually start there I go, I've said actually again. Since we don't start a database, but we start an instance, we should understand what these two things are. Let's talk about a database first. We often think about a database as being an entire solution. We go out and we get the Oracle database, we get Postgres, we get Mongo, we get SQL Server, etc. But in Oracle speak, The database is the data itself, the data at rest. It's just the files that are sitting on whatever storage platform you have. The thing that processes that data is known as a database instance. And what an instance is the actual programs that run the Oracle software. It is a list of processes, the usage of memory, etc., the concept of programs that are actually reading that data and writing that data. So we have this distinction between the database, which is just the files sitting on disk, and the instance, which is the programs and processes and memory that is required to actually access that data. I swear if I say actually again, I'm going to explode. We often use the terms interchangeably, database and instance, because it doesn't really make a lot of sense to have one without the other. I can have a database sitting there, but nothing to actually process it, or I could have an instance with no data behind it, and obviously that's not very functional as well either. The reason we have the separation in the Oracle terminology is that it isn't necessarily a one-to-one relationship. For the vast majority of us, it is. We have a single database, and the thing that accesses that database is a single instance. And that's the combination of the two that provides services out to the outside world. However, for a long time, Oracle has had a clustering technology. It used to be called Oracle Parallel Server way back in the day when I first started using Oracle, and now it's called Real Application Clusters, both of which are the concept of having a single database but multiple instances, each running on multiple nodes that can access the same shared data. That's why we have this important distinction. So what are the files that make up the database? If we head back in time, we can see in the earlier versions of Oracle, the concept of files was fairly simple. We had what we call the data files, where your data lived. We had the control files, the initialization files, and the log files. As Oracle has evolved over the various versions and years, the number of files we start to see has increased. We now have a thing called a SP file, a password file. We can have external tables in the database which actually access files totally outside the database. We have what's called wallets for security, and we can have things called B files, which are large object types referred to from inside the database that actually refer to files sitting outside the database. Once we get into the more recent cloud technologies, we can also access files that don't even exist on the same servers as our database via some of the common cloud technologies such as object storage, or even accessing files in other technologies such as Hadoop, etc. But for most people, they think of the Oracle database files as data files themselves, the control files, the initialization files, and the log files. Those are the four broad categories. Let's have a look at them in turn. The control files are critical to the operation of your database. In fact, if you don't have them, you can't even start your database instance. In earlier versions of Oracle, typically control files were just a few megabytes, but nowadays they can be much larger, and we'll get to why shortly. The control files contain metadata which describes the database such that the instance can access it. Inside the control files, the key things you'll have in there are information about the data files, some general information about the redo logs, the redo log history, and sometimes information about the backups you've taken. For each data file, the control file will contain information about what the data file path is, so we know how to find it, what the size of the data file is. In more recent versions of Oracle, it will contain the block size of the data files, because each data file can contain different block sizes nowadays. We'll talk about blocks later on. It contains the data file status. Just because a data file is listed in the control file doesn't mean it's available to the database. It could be offline or inaccessible or missing. And it also contains the information about the SCN number for each data file. That's a topic for a later podcast. The kind of general information you'll find in the control file is things like the number of redo threads, the total number of files or data files in the database, whether the database is in archive log mode or not, and various other information that helps define the database itself. The redo information is the list of the redo logs that are accessible by the database, the size of those redo logs, and also the number of threads. And threads become particularly relevant when we start talking about clustering solutions like real application clusters. We also contain the history of redo log, and if you've ever queried v$log_history, you'll see that the database actually contains a record of all the times the redo logs have been switched or have they filled up, etc. This is critical when it comes to instance recovery. And the final thing we see in control files is backup information. This is when you're using Recovery Manager without a Recovery Manager catalog. This is one of the reasons why control files have got considerably larger over time, and anyone that's using control files for their backup repository will be familiar with the parameter control file record keep time, I think, which is the number of days of information we keep about backups inside the control file. Now we can move on to the data files. And as you'd expect, the data files mainly contain your stuff. All the information that actually is the reason you chose to use the database in the first place. The data file also contains some header information that describes the data file itself, but the vast majority of it is your data. Your data is stored in blocks, and if you're familiar with file systems, you'll know that when you format a disk or a USB drive, etc. on your PC, then you typically get to nominate some sort of thing like a block size or a page size or an allocation unit size, etc. The Oracle database works in the same way in that you nominate a Oracle block size at database creation time, and you can also nominate it on a tablespace by tablespace level. The reason Oracle has its own block size is Oracle runs on multiple platforms, and as a result, in terms of having a consistency of the blocks, we need to use our own block size, because the Windows file system the database is sitting on might have a 1K block size, might have a 2K block size. If you're running on Linux, the Linux file systems might have a 512-byte block size, etc. There are so many differences in the underlying architecture for file systems and the like that for Oracle we need to have a consistent block size as an abstraction away from the file system specifics. The most typical Oracle block size you'll see, and the default if you create a database with all the default settings, is 8 kilobytes. You can choose anywhere between 2 kilobytes up to 32 kilobytes on some platforms, but the vast majority of databases out there are running on 8K. If you trawl the interwebs, you'll see huge amounts of historical debate about what the best block size is and how bigger block sizes are best for data warehouses and tiny block sizes are best for OLTP systems, etc. One of the things that's often missing in a lot of these debates is any concrete evidence of benchmarking to prove the assertions about different block sizes. In the many years I've been using the Oracle database, I've never seen a database dramatically improve its performance characteristics by moving to a block size larger than 8K. There have been some particular niche examples where that has been useful. For example, a database where it turned out that almost every single row in the database for a particular table was just slightly larger than what could fit on a single 8K block, and therefore moving to a 16K block size was beneficial. But in terms of overall database performance suddenly being transformed just by moving to a larger block size, these are very, very rare. So staying with 8K is probably fine for 99% of people out there. Conversely, moving to a block size smaller than 8K also sits in the niche category, but can have significant performance detriments for those people that use it on a typical file system. One of the things I commonly saw in early versions of Oracle were non-8K block sizes being run on top of file systems which did all of their I/O operations in 8K chunks. As a result, every time you wanted to write, for example, a 4 kilobyte Oracle block to disk, we would need to read, say, an 8K block off disk because that was the file system unit size, merge the 4 kilobyte Oracle block into it, and write the 8K back. My understanding is that's probably the most dominant reason why Oracle opted to move to an 8K default block size to solve those issues with file system incompatibilities when it came to performance. Interestingly, back in the early days of Oracle, the 2K block size was indeed the default. The reason it was the default was Oracle shipped us a default initialization file that we would use to create any database. And it used to simply have the 2K block size being the smallest as the option that was commented in, while 4K, 8K and 16K were commented out. I learnt this the hard way because I had built many a database using a 2K block size because it was the default, and performance was not stellar, but I was blissfully unaware of this. It was in the late 90s that an Oracle performance legend by the name of David Ensor came to Perth to do a talk on common mistakes DBAs make when they are new to the Oracle database. And one of the first things he popped up on a slide was, who is using the default 2K block size? And unfortunately I put my hand up and he said, if you move to an 8K block size, you will be a very happy DBA. So I then built my next database as a clone of an existing database which was built on a 2K block size with an 8K block size, and we had fantastic performance benefits because we were running on top of a Solaris file system which worked best with 8K blocks. Having to deal with the complexities of file system block sizes and the appropriate Oracle block sizes to match is perhaps one of the things that led to the popularity of raw data file usage in early versions of Oracle, where we simply bypassed the use of a file system altogether and let the Oracle database talk directly to the disk using what we call raw devices. That concept was obsoleted by the introduction of a thing called automatic storage management, which is effectively a disk volume management solution implemented by the Oracle database itself, therefore removing the need to have a file system layer at all to have your database running in optimum mode. The vast majority of Oracle databases now that are not sitting on top of a file system are using automatic storage management as their dedicated storage solution for the Oracle database. And in fact, ASM has been so successful that raw devices are now desupported in the Oracle database and are no longer used. And the final type of file that every database must have is the redo log files. The redo log files contain every single change you ever make to the database and effectively form a journal of every single operation you've ever done. You could make an argument that the data files in the Oracle database are really just a performance enhancement in order to give you a point-of-time copy of how your data looks. Because if you took a database from empty and simply applied every single operation that can be found in the redo log, you would over time get the database to a state at which it currently sits at. Every insert, every update, every delete is captured in the redo log and therefore forms the entire history of all the data in your database. Thus, theoretically, even without the data files at all, if someone did a query to your table, you could simply search every single redo log, apply every single change, insert, update, delete, etc. that can be found in the redo log for that table, and once you've applied all those changes, you would now have the table as of its current state in time. Obviously that's not practical, which is why the data files are there to give you effectively a starting point. I remember giving talks to DBAs about database backup and recovery, and I always said the data files are nice to have, but the redo logs are the most critical part of every backup. So that's a quick introduction to the files that typically we would say make up the database. As I mentioned before, there are lots of other files that are critical as well, but generally it's control files, data files, and redo logs that are what we think about when we talk about the term database and data at rest. Let's now move on to the instance, the programs, the software, the processes, the memory that provides the services to read and write and use all that data you have stored in your database. When I first started using Oracle, the list of processes you would see that were running the instance was quite small. We would have PMON, Process Monitor, SMON, System Monitor, LGWR, Log Writer, DBWR, Database Writer, RECO, the recovery process, maybe some others if you were using multi-threaded server, but that's typically what you would see around the version 7 timeframe. As Oracle has evolved, more and more background processes have been added to reflect two things. One is a particular existing process was being overwhelmed with too many functions to perform. For example, the checkpoint process came in Oracle 8 to take the checkpointing load off an existing process to make it a dedicated process. Similarly, we started having things like the job queue, specialized lock management services for real application clusters, queue management servers, etc. that came along in version 8 and version 9. In version 10, there was a big jump in processes as we started to do more automated stuff. So you would start seeing things like MMON, the memory monitor, MMNL, memory monitor lite, RBAL for ASM rebalancing, etc. More and more processes coming along, each with more targeted usages as the Oracle database evolved to do more work on your behalf to ensure that it kept performing and was diagnosable either in real time or after the fact. If I jump ahead to version 19, just logging onto my Windows box, I can see that there are 417 potential background processes, and on my machine here, 104 of them are in use on my Windows home PC. So the number of background processes has certainly climbed over the versions of Oracle. If you're interested in seeing what background processes you have yourself, you can always query the v$bg process table. That will list all the potential background processes, and there's a column there called PADDR, process address. If that is non-zero, then this means that background process is currently active and started on your machine. That's how I worked out I had 104 out of the 417 running on my box. If you are running a Unix system, you can simply log on to the operating system and do a simple process listing command, and you'll typically see those large numbers of processes for each Oracle instance that you have running on that machine. On Windows, it's a bit more interesting in the sense that if you fire up Task Manager, you'll typically only see a single process, a program called oracle.exe. This is because on the Windows architecture, we use a thread-based system because Windows is more architected towards using threads rather than individual processes. However, if you have the tlist command, you can do a listing of the threads that make up the Oracle executable, and you'll see similar background processes, even though they are threads for the Oracle database. As servers have got more and more powerful over the years, you can start to see the motivation for our technologies such as pluggable database or multi-tenancy as we call it. Whereas server power used to mean that we would run perhaps just a single database instance on a machine, the incredible number of cores and firepower in servers means we can run many instances on a single machine. And if each of those instances has hundreds of background processes, even though those processes themselves typically will be sleeping and not doing much, the operating system now has a lot of background processes to constantly flick between to see if they need work. Thus, using something like multi-tenancy and the pluggable database architecture means a single instance offers multiple logical databases out to the outside world. Running 2 instances, each with 100 processes, is trivial for a server. However, running 2,000 instances, each with 100 processes, is something altogether different, hence the motivation for pluggable database technologies. So we have processes, instances, control files, data files, etc. Let's cycle back to that simple comment on the Stack Overflow question, which was you need to start your database, and why it really should have been you need to start your instance. Let's walk through how a database instance will start. There's very little you need to start a database instance. It's getting it to a fully running state where things start to get more complicated. All you need to start a database instance is an initialization file, which controls things like what the instance name is, how much memory to allocate, etc. This is what we call a no-mount start, and you can do this yourself on the database by running the startup no-mount command. We read the initialization file, allocate some memory, and fire up the processes I mentioned before to have your instance running. It doesn't have any data files yet. It doesn't even have any control files. All it is a list of programs and memory structures waiting to do something for you. But the initialization file also has a parameter nominating where the control files are. That leads to the next phase of starting up, which is mounting. When you mount the database, your instance uses the information from the initialization file to locate the control files. Assuming the control files are existent, then inside the control file contains a list of where the data files are and what status they are in. At this point, the instance now knows about the control files and the data files. The database is now what we call mounted. The instance knows where the data files are stored and whether they might need database recovery in order to bring them consistent before allowing the database to be fully opened. Assuming the database was shut down cleanly before we did a startup, no recovery will be required. And finally, we can open the database, which will allow people to connect to the database and use the Oracle database in conventional fashion. Hence, we don't really start an Oracle database. We start an Oracle database instance and then mount the database in order to, for lack of a better term, attach the database to the instance or multiple instances if we are using real application clusters. Suffice to say, I never got a response to my comment on that Stack Overflow question saying, no, you don't start the database, you start the database instance. But I'm hoping that the poster of that comment got the subliminal message that perhaps being a little bit more polite on forums is the best way to go. So I'll finish off this podcast by returning to its inspiration, namely good etiquette on technical forums. When we see questions on forums and our immediate reaction is that person is being lazy or that person hasn't put in the effort, I feel that's an unfair response, even though it's often a natural one. I don't think on forums we have the right really to call someone lazy or ignorant, because sometimes even the simplest of answers are simple to us because of our experience in terms of we know which terms to type into our Google search. We know which search results are probably going to be valid versus which ones might be just leading us down a rabbit hole of misinformation. And even if someone has Googled and come across the right search result to click on, sometimes that is reference material. And reference material, while being valuable in, for example, the Oracle documentation, sometimes it's not the solution-based information that is desired, which prompted someone to put a question on, say, Stack Overflow in the first place. Even for those questions where it seems to sing out to us that this is someone who is looking for a shortcut to doing their homework or passing a certification exam, even then, I don't think it's appropriate that we try call them out or insult them by calling them cheats or lazy, etc. If we honestly believe they are trying to circumvent some process, then maybe we just give them enough information to encourage a two-way conversation. Maybe we ask them some more questions to get them trying to think about the solutions on their own bat. Don't get me wrong, no one's perfect. These are behaviors I aspire to be, but I don't always reach those goals. Sometimes I can get quite snarky, whether I'm answering questions on Ask Tom or Stack Overflow, etc. But I think we should always aspire to assuming the best, even when those questions seem to be either poorly worded or lazily worded, or someone hasn't put in their due effort toward assisting them to giving more information. For example, you could say, could you give us a fully working test case to try help explain the issue? If they are indeed lazy, they're not going to reply, but you haven't been rude. If they are just, for example, new or inexperienced, or perhaps even just shy, then engaging with those extra questions, those extra prompts, encourages that two-way conversation, and you've actually helped someone along with their IT career. I think that's a far better place for us to be than to be jumping on the RTFM, let me Google that for you, etc. bandwagon. So I think that'll just about do it for podcast number 1. I hope you enjoyed listening. I'm pretty new to this podcasting game, so if you have feedback, please reach out to me on Twitter or via my other social media channels, and hopefully I'll see you in the next one where we continue talking about Oracle database basics and fundamentals. But obviously, please, if you have some topics you'd like to discuss, reach out to me and we'll slot them in. Catch you on the next one. Thanks for listening to this podcast. The music credit goes to Zanman from Pixabay Music.